We went by bicycle. No automobile available because of wartime restrictions on their use. On the way home, my condition began to assume threatening forms. Everything in my field of vision wavered and was distorted, as if seen in a curved mirror. I also had the sensation of being unable to move from the spot. Nevertheless, my assistant later told me that we had traveled very rapidly. From the Diary of Albert Hofmann, Swiss chemist, 1943. Switzerland has long been obsessed with the science of the mind. Take Albert Hofmann. He was the first person to synthesize LSD. On April 19, 1943, he ingested a tiny amount, hopped on his bike, and then realized that all matter is merely energy condensed to a slow vibration. There is no such thing as death, and we are the imagination of ourselves. Today, Swiss labs and medical companies are still pushing the frontiers of our understanding of the mind. There's less blotter involved, but they're very much turned on and tuned in to a unique mix of neuroscience, computers, and AI. The research can be dazzling. It can sometimes feel like you need an IQ of 1,000 to understand it. But more and more, I'm seeing that we're on the cusp of things that used to be called miracles.
And now you're going to turn on the stimulation and do a leg extension. And up, the steam is on now.
How does it feel when it turns on like that?
It's fantastic.
6 years ago, Michel here was in an accident that left him unable to move his legs at all. Then he had electrodes implanted on his spine. And, well, check him out. He's one of the first patients treated by Onward, which has created a technology to help reconnect paralyzed people's brains with their bodies. The idea comes from a brain surgeon and a neuroscientist, Jocelyn Bloch and Grégoire Courtine. Several years ago, Grégoire was studying paralyzed rats at UCLA and came up with a way to get their legs moving again.
So very simple approach at the beginning, stimulating the spinal cord electrically, a region that normally controls leg muscles, anatomically intact after a spinal cord injury, but disconnected from the brain. And it was quite amazing because as early as you apply the stimulation, the animal would start stepping automatically on the treadmill.
When I met him, I saw the mice and rats walking, and it was fantastic. The idea was to bring it to the human being.
I don't think the average person knows that this is even possible right now. Maybe explain what you're finding people are able to do.
If you have a spinal cord injury, your brain is intact, giving a command to your legs, but this command is interrupted at the level of the injury. And the idea of the treatment is to reactivate the disconnected part of the spinal cord in order to then activate your legs. So how do you activate this part of the spinal cord? With electricity. So this is what we call the paddle lead. It has 16 electrodes, as you see here, 8 and 8 in parallel. And we implant this paddle lead in the dorsal aspect above the spinal cord.
The electrodes get implanted on a different part of the spine depending on what the patient is trying to do. Place them on the lower spine, and you can get the legs moving.
When the first patient stood up, I don't know, in my head I'm picturing everybody crying and hugging. What was it like, or is it more?
Here you are in Europe.
Yeah.
With Italian, with a lot of emotion. So there was a lot of bad words.
Yeah. So, but it was a big emotional.
Yeah, it was like, hi.
In other patients, the electrodes are placed higher up on the spine to help regulate blood pressure, a less obvious but equally life-changing effect.
My name is Julie. I'm 23 years old, and I'm an archaeologist. 1.5 years ago, we had a major car accident in Serbia, and I basically broke my neck. My condition of blood pressure issues got so bad that I was basically like what you guys were looking for in the study, and then we came here and
Yeah, and
got implanted.
I did not know that blood pressure issues are something that's quite common with this type of injury, but it is.
My blood pressure is so low that I'm basically just stuck in bed all the time. Even just sitting up in a wheelchair is like running a marathon.
Yeah.
It also has a huge impact on my mental state of mind.
Yeah.
Without the stimulation, there is so little oxygen circulating in my brain that there is not much joy in life, let's say. And then when you turn it on, it's like back to some sort of normal level. And it's just the increase of energy, being able to breathe and speak at the same time. I'm able to make plans, to travel, to just have a more positive outlook on life in general.
Now it's still a little bit of a warm-up.
Michel is a young man who had a motorbike accident a few years ago already with a complete motor and sensitive paralysis.
Okay.
And this is a real athlete. He trained a lot with us, and he's using this technology every day, many hours.
I have 2 buttons, one per side. Every time I press, I send the signal to the tablet, and I have the movement. I make the step.
The walk may be strained, but it's good enough that Michel is mostly able to get around without a wheelchair. And the implant lets him do other kinds of exercises too.
He has a program that just targets the region of the spinal cord involved in trunk muscle. So he is uploading the program.
Just pressing a button, I have the 6-pack.
Oh, wow. I need this program.
Rather fantastically, Michel, whose legs were completely paralyzed, has regained a tiny amount of homegrown organic muscle control.
Something in my body is changing. Now is appearing some twitch on the muscles.
Okay.
Under the lesion.
Yeah.
We know that the residual nerve fibers, because there are always some residual nerve fibers, they grow because of the stimulation, and that improves the communication to the point that they can regain control over their paralyzed muscles.
The doctors don't know how far the regrowth of nerve fibers can go. With only a handful of patients implanted so far, there's still much to learn. But there are other ways that Jocelyn and Gregoire want to push the tech forward. They have started to combine brain-computer interfaces with the spinal implants. That is to say, they're putting electrodes in the brain and on the spine and having them communicate. This lets patients simply think about actions like walking or swimming and have their bodies pick up on their desires.
What do you think? You going brain implants?
I have to cut my hair.
2 years ago, Onward went public and raised $100 million. They're still in the clinical trial phase with much of this work, but are on track to become the first company to commercialize these kinds of implants. The hope is to get them covered by insurance and accessible to the millions of people around the world living with spinal cord injuries.
Every time I see him progressing, each time I see him, it's very rewarding. On the other hand, it's very frustrating because I would like to see 1,000 Michel.
It's very cool, man. I can tell you're very focused.
Every day I want even more. Every time I want more.
As Werner Herzog said, the fountain is life or a tourist attraction. It's totally up to you. This is Geneva's fountain hotspot. It's beautiful, ejaculatory, everything you could want in a fountain. Do you want me to do a straighter one?
I'm not gonna lie, I didn't exactly do my homework on the touristy bits of Switzerland.
Is this Lake Geneva? Let's find out. I'm not getting a clear answer on that, but we're gonna go with it.
It's nice, as you can see. But me, I'm just here for the brains. And in cities like Zurich and Lausanne, you can find some of the world's brain research hotspots. Here, neuroscience and computer science mix promiscuously with wildly creative results. For example, this lab, full of rodent Twitch streamers, run by animal research superstar Mackenzie Mathis.
So it sounds a little bit far out, but we really teach mice to play video games and use little joysticks like pilots. But the cool thing about this is that we then allow to see how they learn these different skills and how they adapt, and at the same time can record the neural activity. And we hope to turn sort of the lessons learned in the brain into literally new AI algorithms.
What are we gonna see today?
So today we're going to take you into the lab and show you some of the latest gen video games for mice. They're kind of in a freely moving world, but all the world is a screen, and it changes based on their real-time movements.
This is the VR world.
Exactly.
Are we gonna put a mouse in?
We're going to put a mouse in here. Yeah. So if I'm not mistaken, this is anchovy and barracuda.
So who is that?
This is anchovy.
Anchovy's off. It's this idea of they're learning this game, they're facing challenges, or they're going through this environment.
Exactly.
And it's just what is the brain doing as they try to like negotiate that and figure things out.
Yeah, exactly.
Oh, what did she do?
She made the things appear by standing in the middle and then facing with the right heading angle at the screen.
Anchovy may be impressive, but she has yet to enter her final form.
So in order to be able to measure the neural activity, what we do for part of the experiments is to replace the top of the skull with a glass plate. Behold,
mouse brains.
This mouse had this surgery, and now she's learned to play this game.
I think the mouse treadmill is so funny.
The mice themselves are genetically engineered such that in some neurons, their neurons actually glow green. And then you can capture this with a camera, and then we can extract sort of the regions of interest from all these different neurons and then analyze them in relation to the actual gameplay or the actual behavior of the animal.
The ultimate goal is to turn these mousy thoughts into data. Mackenzie wants to record how brains function in certain situations and use those insights to inform and shape AI systems. In other words, she wants to use real brains to make better artificial brains.
We hope by trying to understand, like, literally the algorithm or the computations, like, are they using arithmetic? Is it calculus? Like, what are they doing? And how can we potentially take those sort of computations and then test them in new AI algorithms? So that's the general idea.
Mice are nice and all, but they're not the only critters having their brains scanned here at Swiss research institutes.
These are our fly stocks, so each and every single one of these fly vials contains flies that are genetically distinct.
Meet Anna Maria Jaksik, the queen of the flies.
We normally have to anesthetize them because they're flies, they fly. So we have to kind of keep them nice and still. Your objective is to find males versus females. Let's do that.
The male is the dark butt, right?
Let's see.
Yeah.
Yeah, that's correct.
That's right?
Yeah. You're a natural. So our basic question in our lab is, in complex environments, you have to learn where things are, you have to memorize things. So we're trying to kind of recreate these situations for the flies. and we try to evolve cognition in flies.
So you're trying to make super smart flies.
Yeah, exactly. So fly masterminds.
What could go wrong?
Like this, yeah.
So you breed smarter and smarter flies. You get them to do these tasks. You find which ones perform the best. Take those, breed them again.
Exactly.
Okay.
It's basically fly eugenics. But how do you separate the Fleinsteins from the Flimbacills? With a fly Q test, of course.
So right now we are conditioning flies to pick one color in a set of 2 or 3 colors. They're picking between green or blue. Every single fly at the very end of the experiment will get a learning score. We get rid of the 10% of the worst performers, and we take the majority of the flies.
Okay.
So.
As she breeds generation after generation of bugs, Anna Maria hopes to learn about the relationship between genes and intelligence.
We can track specifically what are the genes that are being selected for cognitive behaviors, how specifically does the brain actually change in its structure, and all of this we can actually use for wetware. So instead of using physical chips, we can use biological chips like neurons itself to actually power our computers someday in the future, you know.
Yeah. I think every scientist I've interviewed for this show so far just about is like trying to make AIs smarter and better. And
it's the ultimate kind of goal to see how to produce ourselves, right?
Yeah.
In many ways, even the tiniest corporeal brains are smarter than our best AIs. So the researchers here think that studying these creatures is our best shot at creating things like highly capable robots.
If we could build an AI that could do what a mouse does, I think that would be a huge feat for humanity. Maybe within 10 years we could have, mini mice robots. Not that we want that for humanity, but conceptually, right? We want something like an embodied agent that can act in the world and very adaptively change its behavior.
I just pictured like New York full of robotic AI mice. This is horrifying.
That would be pretty scary.
Of course, the brain I want most to understand is my own. So I decided to volunteer as a test subject. Okay, friends, ready to go down the rabbit hole? This lab at the Swiss Federal Institute of Technology is run by an eccentric psychonaut named Olaf Blanc. He invited me to try an experiment that's meant to induce the feeling of a ghostly presence. Real talk, I'm a little bit scared. But first, let's get existential with Olaf.
So I've been interested for a long time in the self and how it is related to our body, how the brain actually represents our body, how are my hands represented in my body, how is your brain representing your body. What gives us the conscious experience of being someone, of being a person? We're looking at something very perceptual. We call it a minimal self. And we think that this minimal self is crucial for feeling that I'm feeling right now sitting in front of you here talking to you.
So this very basic fundamental connection between mind and body.
Exactly, so it's an active brain process.
Yeah.
On a millisecond by millisecond basis, we have to generate this representation where we are in space, and it better be here, so where my body is located.
We take this for granted, but this process is happening all the time.
I think much of
Well, except when it isn't. Think out-of-body experiences or feeling a ghostly presence in the room. Anomalies that Olaf first encountered while treating patients with neurological disorders.
They were talking, for example, that before they have an epileptic seizure, they may have an out-of-body experience.
Okay.
And of course, they didn't use that term, but they were saying, yeah, listen, Olaf, it was strange. I had the sensations for about a couple of seconds that I was above myself, or it could have been a presence hallucination or ghost sensation. I remember one patient in particular who told me, well, there's somebody just at arm length behind me. And whenever she got up and moved, that person moved along.
Okay.
So very strange.
So is your theory that stories of ghosts over time. This is kind of where it all comes from. Is some people having these feelings.
If you want a naive, quick response, yes, that's what it is.
It turns out these sensations are a common symptom of Parkinson's disease.
So the presence hallucination, feeling somebody behind you that is not there, that you can't hear, that you can't see, 50% of Parkinson patients will have that.
Naturally, this inspired Olaf to figure out how to induce these hallucinations on demand, using VR and robotics.
So you will be sitting on this chair, and your main task will consist in moving this robot.
Okay.
Can you confirm you are in a dark environment right now?
Yeah, nothing, just black. Oh, there you are.
You can see that he's immersed inside a virtual room, which is mimicking this real experimental room. So it's a recreation of the room in 3D.
As I moved my hand to poke a virtual avatar, a robot behind me gave me a corresponding poke. It's all meant to confuse your brain so much that you start to sense the presence of another being, while Olaf studies what's going on in your brain.
Thank you.
Okay, perfect.
That was weird. Sometimes I sort of thought I was doing it, and then sometimes it really felt like almost like an animal or something was kind of kneading in my...
The sensation, for me, was not all that strong. But that's partly the point.
Il y a eu un moment de montée d'adrénaline, c'est de me dire qu'il y avait quelque chose derrière moi, quelqu'un.
Since Parkinson's patients are more susceptible to the illusion than others, the experiment could function as a kind of early warning system for the disease.
With a robotic device, we don't need to wait for the symptoms. We don't need to wait for the patient to have Parkinson's, but we could expose people to this much earlier if they have other risk factors. And if they would be part of this very elevated sensitivity, we could team up, for example, with companies starting very early neuroprotective therapies, trying to delay the onset of Parkinson's or cure Parkinson's.
What an exciting time between VR, brain-computer interface, artificial intelligence. I mean, it must be like exhilarating to have this intersection of all this.
No, it's absolutely so. I think what is special about this time, I think, when I started, neuroscience was neuroscience, philosophy was philosophy, and certainly engineering was engineering.
Yeah.
There was always an interest in medical applications, but what is really amazing happening now is it doesn't matter anymore, right? We're all working on similar problems and issues and want to resolve this. The brain is, I think, by definition, something that's fascinating for everyone, and it needs expertise from all these domains, I think, to have even a chance to understand small parts of it.
80 years after Hoffman's psychedelic ride, Switzerland's brain research complex is still going strong. But the mysteries of the mind remain mysterious. We still don't really know how billions of neurons firing creates a thought, or how to fully restore a broken connection between mind and body. Researchers here will be on this quest for a long time to come. But it's a journey worth taking, and I'm excited to see what's next. That is, as long as it's not AI rodents bent on our destruction.